Hello everyone, this is Dr. Garrick, Labor Economics. This is Labor Supply Chapter 2, Part 14. In this part, we are covering labor supply elasticity. Labor supply elasticity measures the responsiveness in hours to a change in the wage rate. So, what's the impact of percent change in the wage rate? Percent change in wage rate on the percent change in hours. Okay, so elasticity, labor supply elasticity, we use the Greek letter sigma. This is sigma. It shows the percent change in hours worked divided by the percent change in wage rate. Formula is like this: sigma, labor supply elasticity, equals to percent change in hours divided by percent change in wage rate. So percent change in hours is change in hours divided by initial hours. Everything divided by percent change in wages divided by wages. So it is final hours minus initial hours. I put 2, 1 divided by initial hours. Everything divided by final wage rate associated with the H2, final hours. Initial wage rate divided by initial wage rate. Everything multiplied by 100. Okay, so it's basically the same thing. Change in hours means final minus initial. H is the initial, right? So if you want to write down 1, 1, this is H2 minus H1, W2 minus W1. So let's calculate elasticity. For instance, what happens when the wage rate goes up from $10 to $20? And when the wage rate was $10, you were working 1,900 hours a year. Wage rate went up to $20. Now you're working 2,090 hours per year. So actually, wages went up. You are working more. Okay. So which effect is dominating? You drop the leisure. So substitution effect dominated here. Okay, there is a positive relationship between them. So it's the first part of the labor supply curve. So here, before the upward bending part, hours, you have wages here. Okay. All right, so you have substitution effect dominating. Okay. So let's take a look. Let's calculate the elasticity, labor supply elasticity. We're going to do final hours minus initial hours divided by initial. Divide everything by final wage rate, initial wage rate. I always write it divide by initial wage rate. So you have to label everything. Initial wages $10, final wages $20. I'm going to start with the numerator, top part. Final hours, H2 is 2,090 minus 1,900 divided by initial hours, 1,900. Okay. Bottom, wage 2, $20. Final wages, initial wages, $10. Divided by initial, $10. Okay, so let us see. So this is 2,090 minus 1,900, 190 divided by 1,900. Okay, and you have 10 over 10. That is 1. Okay, so you have, what do we have here? Okay, you have not 190 divided by 1900, 0.1. Okay, you also need to multiply numerator and the denominator with 100, but they cancel out. All right, so 0.1, this is a positive number. Substitution effect dominates. Okay, and in English, this means if the wages go up by 1%, you're going to increase the hours by 0.1%, or multiply this by 10. If the wages go up by 10%, you're going to multiply 0.1 by 10. You're going to work 1 more hour. That's what it means. Okay, so How do we decide? We found elasticity to be a positive number 0.1, all right? If the absolute value of the elasticity, absolute value means if it has a negative, get rid of that. If it's less than 1, we have inelastic labor supply, which is our case. 0.1 is less than 1. We have inelastic labor supply, which means wages go up by 1%. Response in hours of work is less than 1%. In this case, wages go up by 1%. People increase their labor supply by only 0.1%. And vice versa, if absolute value of the labor supply elasticity is positive, we call that elastic labor supply. If we found elasticity to be 5, in English this means positive 5, 1% increase in wages will cause a 5% increase in your hours worked. Okay? Elastic labor supply, very responsive. So estimates of labor supply elasticity, so use of regression models, we actually talked about in the appendix of the previous chapter. So we regress hours of work of various people, let's say 60,000 people, on their wage rate, their non-labor income, and we control for other things. So we're trying to figure out the coefficient estimate of beta. If you have beta positive, okay, which means wages go up, then hours went up. That means leisure went down. This is the substitution effect dominating. Substitution dominates. If beta is negative, which means in English, beta negative means one goes up, the other goes down. They move in opposite directions. Wages go up, hours went down. Why? Leisure went up actually. This is income effect dominating. You feel richer. Okay, so this is the bottom part of this is the top part of the labor supply curve, the backwards bending portion. Okay, so research shows that labor supply elasticity of prime age men, which is 25 to 44, is negative 0.1. Okay, so what does this mean in English? It means 1% increase in wages, 1% increase in wages causes a 0.1% decline in decline in hours, which means income effect is dominating. Okay, but it's very weak effect. Just keep that in mind. So they actually decomposed it, economists, and they found that income effect is about negative 2%. So there's a pure income effect pushing your hours down when wage goes up by 2%. When wages go up by 1%, substitution effect says it's going to go up about 1%. So as a result, the impact is very small. So labor supply curve, in absolute value, this negative 0.1 is 0.1. So it's less than 1. That means inelastic. Labor supply curve is inelastic. So labor supply does not respond too much to a wage change. So consensus estimate from credible studies shows that income effect dominates. All right. This may explain why hours of prime age men declined from 1900 to 2000. Okay. Because there has been a secular rise in real wages, but workers are not responding to these changes. They are slowly dropping their labor supply. Okay,